All right, guys, hello, welcome to another review. I still receive messages from students that are confused about what can be happening, right? So you did not understand that infomercial I showed you last review session. So let me just again rehash. You have this message. It says that if it's daytime section, then okay, so that the final section map will appear here. The final exam for daytime sections will be held from 1 to 3 on Tuesday, December 15th, right? And then they say that there is an evening session. You see, as far as I know to this moment, I mean, actually, there might be a message from Professor Suzuki, and I will let you know more certainly, right? And let me actually check if there has been a message now. Maybe it already has arrived. Yeah, it did arrive. Let me see what he says. So he says no problem. In other words, there is no problem. That's it. That's it. Everything is good. So again, listen very simply. You are all registered under one section, right? So there is this message saying that you should be able to take the exam from 6 to 8. But I believe due to the error within the department when they were scheduling it, there was only one link. So the evening and morning sections received the same code. There is only one class, only one roster. Do you see? Grade book. You see, 73 students, they're all together from both classes, right? Out of 80 students, there are 73 that are here registered to and ready to take the final. If you're on this roster, then you should be able to see the final. Is it clear? And because you're all together, I don't think the system goes, oh, very smart. Oh, you look like an evening student because you have, like me, bags under your eyes, right? I think the system thinks, I don't care, right? The exam is scheduled. Look, guys, look at here. Look what it says. Available from 1 until 3:30, right? So although technically you should have had, the evening students should have had the evening session, because I noticed this mistake very late, I was sure that they are trying to avoid the exam being leaked to the other sections, you see? So I thought they wanted to be done simultaneously. What other point is there to do exams simultaneously? Uniform, right? So I reasoned not bureaucratically, but logically there. And so I would say it is 90% likely that your exam is, if you're evening students, that your exam is from 1 to 3:30 p.m. If for some reason I am incorrect, don't freak out. If somehow I'm not correct, then your exam is at the regular time. Do you understand? I think 90% likely that the exam is at 1 p.m. for everybody. And if you're an evening student, it could be that I am somehow, there's always a possibility that I'm somehow wrong. I haven't received this information from him. He hasn't said anything otherwise. So I would say at least 90% confident I am that the exam for all of you is at 1 p.m. Do you understand? Please confirm that at least you that came to the section understand it. There are actually not a lot of people. I guess not everybody thinks the review is useful. So go ahead, confirm please that you understood what I just said. And it doesn't apply at all to morning students. Right, morning students, it's morning students. Okay. Alan understood, Christian understood. What about the rest of you? Do you understand? It's very simple. Your exam is at 1 p.m. unless it is at 6. Good? Again, your exam is at 1 p.m. unless it is at 6. That's a perfectly logical statement, right? 90% likely it is at 1. 10% maybe somehow something is amiss still and it's at 6. Good? You have to read, that's by the way a good exercise. That's why when I teach probability, I call it Kafka protocols, right? Because if you read, you should read the book The Castle, so you understand what bureaucracy is like, right? Let me explain one example of bureaucracy. So you see, if you are at the graduate center, you have to have, I remember having to do that. Actually, I never ever dealt with it, right? You have to have a graduate center address, right? It's like a castle that actually has no windows, this place, right? So if you want to email the math department, they're at the graduate center, you have to email them from the graduate center address. But you see, the password is impossible to remember or doesn't exist, or the message or the email address gets erased after a while when you don't access it, right? So then you send the IT people an email saying that you cannot go to your email address. They say, we need your ID, and you scan your ID. We need your social security. We need your past 5 jobs to know about them and why you quit. And once you give them this information, we say, we require that you establish that you're in good standing with the department, right? Which you cannot do because to establish that, you have to message from that email address to the department. You understand? So here you go. Now I understand it perfectly. Hopefully you now understand everything as well. Wonderful. Let's begin with the review. Actually, not a lot of you confirmed. I guess you kind of give up. Okay. Practice questions. Let's resume. Okay, let's now go from question 1 onwards, right? We're now gonna work from question 1 to question 30 something. Okay, here is the limit. Please take 2 minutes, solve it. Okay. Minus 19, you see you have different answers here. Okay. All right, so time is up. It's really a silly question, yes? And let's see how we can input the solution. Look at it, guys. Do you need to add those numbers? Not really, I think, right? So what you can do is this. So F is 3, G is minus 2. So you write 3 multiplied by minus 2 plus 10 multiplied by minus 2 plus 7. Good. And then let's submit this this question, and we are correct. You see, I didn't even have to bother doing anything here. I just submit. I just plug in the numbers. Don't even need to multiply them. Now here is where you add work. See, you can add work, and you can insert, and you can link or image something. Do you see that? You should practice doing that because you will have 30 minutes after the end of the exam to submit your work for all of the exercises. Do you follow? Because if there is some question that say like, wait, this question, I don't care if you did work or not, right? But some questions I would think, did the person solve it? How did they solve it? I want to see. Good? And the system does not automatically give you all the points. Wonderful. Next question 2. Oh, very similar question. So how we solve it right away. You agree? It's not worth wasting our time with this question. So I put a fraction and I say minus 5 minus 6. You see, because f is just 6, and on the bottom I put 2 minus 1. Yes, and I submit my work. What do you know? I'm right. You see how easy it is. So you don't even have to calculate. You see, a lot of you calculate too much. Okay, this is also boring, yes? So we submit this question right away. So tell me what to write, please. So you write minus 5 because that's what f is, right? Plus 8 multiplied by what number there is, by g cubed. So just 0, g cubed kind of no need, g is 0, right? So actually G is everywhere 0, I can ignore it. That's pretty nice, right? This is it's easier than typing it. It's 0, 0, 0. And then we have plus 4 multiplied by x is minus 3 here. Squared minus 7 multiplied by minus 3. Yeah. Plus 4. What do you know? Good. X is not minus 5. F is minus 5. Yeah. So that's why I'm right here. So it's just a kind of a pretty annoying question. So here is another one, also rather annoying. Okay, let's this one, but we will do together. What do I put in for the first part? X going to 1, F goes to 8, G goes to 2, right? So this is still easy enough. So I write G is 2, so it's 2 multiplied by ln of 2 multiplied by 8. There is another, okay, 2 multiplied by, the G multiplies all of it, so don't forget about this extra parenthesis. And then here we have plus 6, I believe, okay? So 6, ln of 2 multiplied by 8, and G is 2, right? So I place this. Now, what do I have here? 2 times G, so 2 times 2, and then I have E to the power of 6 multiplied by 8. Hopefully I put E correctly, right? That's E to the thing. Now here I have root of 2 multiplied by 8 plus 6 multiplied by 2. I hope there are not a lot of questions like this. They're very annoying. And then here we have cosine divided. So here again we have cosine of 8 divided by G, which is by 2. Good. Let's check if I'm right. This I didn't like first one. What doesn't it like about it? Ah, yeah, the 2 does not, it's just written kind of weirdly. You see there's a parenthesis here. So we made a mistake, no trouble, the 2 is here. No? There is trouble, huh? So 2, ah, yeah. God damn it. The ln swallows this entire thing. Finally. You see, well, so good, right? So next. Here is a graph. Yes, so here's a graph, and f of 2 is minus 2, x goes to 2 to the minus f of x is 0, and 2, right? So we have this information here. Which of the following is a graph for f? So here you decide. You can let me know, you can say, you can first specify like a matrix form. You tell me in which row. So I would say this is a first row, second row, third row, and then in which column. Let's say, so for example, this entrance, you can say, you can call it 1, 1. This entrance you can call 1, 2. You see, we're learning matrices. Wonderful, right? So in your answer, you just tell me 1, 1, 1, 2. This would be 2, 1, 2, 2. This would be 3, 1. Do you understand? So that's how you can tell me in your comments what to do. Look at it. 2, 2. Thank you, James. Okay, 2, 2. Come on. What about the rest of you? Are you joining the Soul Train or not? Okay, Alan. Okay, I do not know. I don't care. So I'm going to say 2, 2. Right? Since a lot of you are saying 2, 2, I'm going to trans you. You see what do? You see, so F has to be -2. So we must have everywhere there is, except for this one, there is a dot below. Limit must be, from the left must be 0. From the left, you see, from the left, it must be 0. So, so a bunch of them are eliminated. So for example, it could be this, it could be this. From the right, it is 2. So it's this, you see? So good. Wonderful. So for such things, I don't need work, right? So I mean, there is nothing you need to do more for the such graphs, you know, too easy. But for some things that it's obvious that you had to do work, you know, I would be surprised if you answer it without work. Okay, so here is another thing. So here, limit as x goes to infinity of f of x is equal to -5. At minus infinity, it's -3. So you see, we can already, let's say, so we can eliminate already a few of the graphs, because it has to be to the right -5, to the left -3. So they all the curves must be below the x-axis. So this might be the case. This might be the case. This might be the case. This could not be the case, and this could not be the case, right? We eliminated a few of them. Okay. Now, as x goes to 1 plus, it's plus infinity. This one satisfies it. 1 from the left, it's minus infinity. This one satisfies it. So I'm presuming it's first. You understood how I did it? Yes. Good. So that's fast. Now, next question, 7. Another thing like that. So here you have to write what's the limit as x goes to minus infinity. It looks like it is what? Please write the comments. You have 1 minute. Wonderful, -4. Are you feeling confident about the exam on tomorrow? Yes? You know, I'm almost done grading. Definitely evening students I already graded. I've seen a few cheatings. And I said I'm going to monitor your final exams very, very carefully. Okay, so yeah, I'm going to send a message about it. So, you know, even after the semester is over, expect audits. So what about this one? -2 plus. -2 plus is what in this graph? Four. I approach -2 plus. From the right of -2, what am I going to get? Infinity? Yes, you're going to get infinity. Because -2 plus, you go here. Yes? Infinity. So how do we put infinity? I guess this is what we do. Submit. Beautiful. We have it. Next question. You see, we're moving fast. What about this one? -3, we approach from the left. -3 from the left. What are we going to get? Look at the graph. -3 from the left. Sorry, 3 from the left. Not -3. See, I'm glitching myself. 3 from the left. So 3 from the left, I will get. I confused you guys, huh? 3 from the left It's not minus 3, it's 3 from the left. Be careful here. 3 and a minus. So I'm looking here and I'm going from the left. Be careful, guys. Be more careful than I am, right? So you see this? X going to 3, but from the left. 3 with a minus on top, so infinity. You see? 3 from the left. You're going to climb up. So the answer is this. Understood? Be careful, guys. You see, those questions, if you have them, they're simple, but can be very annoying. You can score... You can make a mistake on annoying problems. Oh, didn't we just do it? Okay, so let's have it. It's x to infinity. Ooh, that makes an entire difference, right? So x going to infinity is what? So g is -1. So we put -1 multiplied by ln of -6 times -8. And then -4. Okay. And here it is -6 multiplied by -1. By the way, explore, do I need to even put a multiplication sign here? E to the power of -4 multiplied by -8. Okay. This one is root of -6 multiplied by -8 -4 multiplied by -1. Good. And yeah, so that's positive. You see, always make sure that it makes some sense. You can say radical, but so this is, if you like radicals, you can say radicals. So the cosine of what? So cosine of -8. That's f, right, divided by -1. Okay, submit. Okay, good. We can move on. Okay, this one. Yeah, so if you put radical 52, it should work, Christian. You know, if you want to, you tell me what to put. You can play around in the practice exams. Play around, make sure what works, what doesn't work when you put it in the system, so you don't have any problems. Okay. You all tried already, right? You go home and you're so excited by this new game, and you of course play with it. Yes. So limit as x goes to infinity, f of x is equal to -2. The limit does not exist at 2. And f of 2 is undefined. Please select the right graph. Is it this graph? Is it this graph? Is it this graph? Is it this graph? Which one is it? So second graph, this one you're saying. So limit at as x goes to 2 is undefined. Yes. Limit at infinity is -2. That can work. And f of 2 does not exist. Yes, it's the second graph. Very good. Next question. Okay, so we have G and F. F is solid, G is dashed. So you have a bunch of limits. So let's see if I can make the screen smaller. Hopefully that will help you see it. Okay. So first, its limit as x goes to -1 with a minus on top, right? minus 1 from the left. What's the limit here? You see? You see? What is this limit, first one? The German just emailed me there's going to be a very hard lockdown in Germany again. No, soon we will experience a similar thing here. Does not exist. Okay. I'm not going to even bother. I'm going to say does not exist since I believe you. Okay. Do you want the explanation here, guys? G is dashed. You see that at minus 1 it's 0. So you think there might be problems dividing here, right? Good. So and then f as we approach minus 1, f at minus 1 is the solid line. You have to be careful. Let's see. Let's actually be careful. So what is f? F approach. So g approaches what? G approaches positive 0, right? G approaches positive 0, and f approaches at minus 1. It approaches some negative number. So the answer should be actually minus infinity. So it doesn't exist. You're correct, but minus infinity is a better way of saying it. Do you see that? F is negative. It's about here. And g, as you approach minus 1, it's always plus 0 plus. So it's a negative number by 0 plus is minus infinity. Good. Now the next one is I approach minus 1 from the right of f divided by g. From the right, it means from here, a similar situation. So I place minus infinity. And then if x approaches to minus 1 of f over g, of course, I place as well minus infinity. And I'm right. You see, I should. It's good. I trusted you, but then I decided no, I'm not going to trust you. So I checked it. It is. Everybody understands what your mistake is. You are correct to say that the limit doesn't exist, at least in the context of calculus, because this is not a number. But minus infinity is the better choice. Okay, Christian. So how is it minus infinity? Let's look at g. G approaches at minus 1. G approaches, doesn't matter left or right. At minus 1, G approaches what? It approaches 0 plus. Do you see that? The parabola is upward. So if I'm slightly different from minus 1, I am at a positive number. So that's 0 plus. 0 plus, yes. Now what happens? So it's a negative number divided by 0 plus, which makes it a minus infinity. Of course, it's not really 0, right? So you don't, because that's the limit. So you all see that, guys? So the answer is minus infinity. It's correct to say it doesn't exist, but the system will mark you wrong because minus infinity is the better answer. Okay, here is another question. So now you have to determine the sign of the following limits. So we have product of f times g. F is the solid, g is the dashed. What's the only the sign? Is it positive or negative as we approach minus 5 or 0? Go ahead, tell me what to select in here. Okay, good. So the first is 0. What happens if x approaches 0? So we're here. What would you say the product of f times g is? Okay, it's positive. So this guy is positive, right? And submit. Wonderful. You understood how I did it, guys? No questions? You see how I knew it's positive? Because negative times negative is positive. Good. Next question. Okay, f of x is minus 2x minus 5. According to the definition, enter the limit in reduced form. I'm not sure what they mean by that. Enter the limit in reduced form. That's we'll try to play around with it. I'm not sure how they mean to enter the limit. H goes to 0. What would you suggest I enter? To simplify it, okay, maybe you're right. So but simplified it. If it's simplified, it's automatically minus 2, right? Because it is yeah. So limit. There's no h. I mean, it is minus 2 really, and the answer is minus 2. Let's see if we yes, in simplified form, it agreed with me.
It's like finding the derivative.
Yeah, by definition though, which some of you did not do. Yes, but you will see it soon. All right, next question. Here, now we have f is solid, g is dashed. So you have to determine the sign of this quotient. Yes. All right, so first thing is what? So that is the limit at h goes to 0. For f, the derivative at minus 3, it will be what? Positive. Do you agree? You see the curve is pointing upwards, so you can clearly see that first part is positive. I hope you see that. How many people answered it? Only 2. It should be immediate. This curve is built of tiny line segments. Where are the line segments pointing? Here, near minus 3, the line segments are pointing up. Okay, what would be the limit for g? What is this limit? Positive or negative? Very good. Now another small question. Which derivative value is larger at minus 3? The derivative of f or the derivative of g? Before I place anything else, I just my separate question. Which derivative is larger, guys? The derivative of f, g is the dashed line, and f is the black line. Which of the derivatives is larger? If I had to say this derivative or that derivative, which of them is larger? I want to see more answers. So people say g has larger derivatives, g. Yeah, that's what you're saying. You're absolutely wrong. Look at it. Which slope is larger, right? Which is more steep? Is it f more steep or g more steep? This line segment is leaning like this. This line segment is leaning like this. This is steeper. F is the larger derivative there. Yes? Easy, right? You understand? Yes. Next question. Here is the graph of F. Yes, do you understand? All you're doing is you're imagining that the curve is built of many small line segments and you're locally measuring the slope of the line segment. That's what derivatives are. Good? So here graph is shown. What's the limit as we go to 0 plus of this function f? 0 plus, look at it. H goes to 0 plus of this at 3. At 3, we're interested here, right? H goes to 0 plus at 3. What would you say about the limit? Is it positive, negative? What is it? I'll give you, this time I'm gonna give you 2 minutes to think about it. So I see people saying negative, again, look at it, 0 plus, where am I looking? Look at this point, 0 plus, I'm asking what's the slope there? Okay, so the line segment here is pointing upwards, so it's positive. Do you see? If it's 0 plus, it means I'm measuring slope from this point to a point to the right. So this line segment is pointing up, positive, right? At 0 minus, the slope is what? Negative. Do you see why? So 0 minus, I'm measuring the slope. Do you see why this is not differentiable? Doesn't the line segments are not gradually changing. It's from negative right away to positive. For the curve to be differentiable, look at it. They have to change very, very slowly. The line segments. They have to change their slopes gradually. Good. And the last part is undefined. Very good. Good. Understood, guys? Nothing so simple. Derivative just means the curve is built of many small line segments. And here it's differentiable because the line segments switch their slopes very gradually. Here the switch is very abrupt. Okay, here is another problem. We have f and f prime have the values that are shown here. What you have to do is you have to tell me what is if g is equal to this function, what's g prime of 5? Clear? And the answer for this particular problem is James, you see, the derivative is at 5. X means already not a number, right? So it cannot be possibly X. Okay. Guys, so it's a very simple problem. Here is how we solve it. Okay, here is how we solve it. So we have f prime of 4 multiplied by 5 squared minus 2 multiplied by 5 minus 50. That's by chain rule, right? Times what? Times 8 multiplied by 5 minus 2. Good. Now this number is, I believe, 40, which means that we are looking at f prime of 40, which is minus 10 times 8 times 5 minus 2. It's chain rule. You all follow? So, guys, do you follow me? You see, I did chain rule and I replaced x by 5 because I'm interested in derivative at 5. Good. So then what am I going to see? Here I'm going to write minus 10 multiplied by 8 times 5 minus 2.
Wait, hold on. Isn't 5 to the second power is 25, and then times that by 4, that's 100. Then 2 times 5, that's 25, and then that's gonna be negative 25, and then you subtract by 50. So isn't it supposed to be 25 for this? Because you're doing
2 times 5 is 10. You confuse with 5 squared, I think, right? Thank you, Christian. Right. So
okay.
right. You see, so first of all, what do I do here? I need this number, right? So this number I have 4 times 25, which is 100, right? Minus 10, so that would be 90. Or basically I can do this. 100 minus 50. It's 50, and minus 10 is 40. So this number is 40. Good. And so I submit my work, and I'm right.
Oh, yeah, you're right.
No trouble. Do you see how I got 8 times 5 minus 2? I just took the derivative. It's 8x minus 2, and I replace 5 instead of x. Good. Yes, guys, all good?
How did you get to minus 10?
Sorry?
I think, where did you get minus 10?
Because the derivative at 40 is minus 10.
Oh, that makes better sense. It's like
Because I
quadruple.
plug in into the derivative of f, I plug this value, I plug 40, so I get minus 10. Guys, so are you clear how I answer this question? Okay. All right, let's move on. Okay, and here is another one for you. Go ahead, solve this one. I'll give you 2 minutes. Okay. Okay, thank you guys. Be careful. Okay, so ready? Look at it. What's the derivative? The derivative of root is 1 divided by 2 root. Root of what? Root of this function at 11. So this function f at 11, it's 13. So it's root 13. Do you understand why I get 13? Is that in the derivative, it's 1 divided by root of what's inside. And what's inside is evaluated at 11. So we have 13. Multiplied by the derivative of f at 11. The derivative of f at 11 is 6. Do you understand? Did you get how I solve this question, guys? Good. I use chain rule. And here's another one of this type. All right, I hope you're ready with this problem as well. So we do it at 3. So what do I put here? I put here 4 multiplied by the expression to the power of 3. And what's the expression? The expression f of 3 at 3. F of 3 at 3 is 4. Yes? And then multiplied by the derivative of this function at 3. The derivative of this function at 3 is by minus 2. Good? So let's submit. And I'm right. Good. Here is another one of this form. Come on, do solve it fast. I bet there is going to be a question like this on your exam, right? They do so many exercises like this. We are almost done with this review, but we are never going to be done. Once you are with me, I will never let you alone. Hmm? All right, I'm gonna go for a minute, and then by the time I arrive, I want to see 13 solutions here in my comments. By the way, I just noticed that when I left, I didn't resume recording. So much of what I said, it's not recorded. I think about 40 minutes to half an hour not recorded. Too bad. Okay, comments? No, not yet. I'm not sure, guys. See, that's a very easy question. What is this dotted thing? It is a what? The dotted thing is a what? Line. And what are we asked to find for the line? Yeah. And what do we need to find the slope of a line? And what do we have? So how long does it take to figure this thing out? You see, it's a question. Don't be, don't hit your head against the wall. Oh, limit, what age? Think about what the meaning is. You are asked to find the slope. Somebody wants you to find the slope where? At this point, near A0. At this point, you want to find the slope. But it's a slope of a line, so you can use any 2 points to find the slope. So the answer is what? The answer is very simply just take those 2 points. So it's the difference in height. So it's 0 minus d divided by a minus c. So the answer is minus d divided by a minus c. That's it. Good? What's there a wow? You see, what's a wow here? The only I look at this thing and I, instead of calculating, I just simply try to understand what am I truly being asked, right? So there is no wow, guys. You should just, many questions are simple if you realize what is somebody trying to accomplish here. Okay, we have a bunch of those limits here, some other things here as well. I don't know, similar questions, I hope, right? You let me know if you want this. We solved something like this today. What about this one, right? This might be dangerous. Okay, suppose a tank leaks toxic chemicals. The area affected is a circle centered on the tank. When the spill is first noticed, the circle has radius 5,000 feet. Response team arrives 30 minutes later, by which time the affected area has grown to a circle with radius 5,050 feet. How rapidly was the radius of the spill changing between the time the spill was noticed and the arrival of the response team? Do you understand the question? The radius. Here is that picture again, right? So do you understand what's happening? I actually have a similar question on my notes. Here, you see that? Here is a similar situation. The spill, radius is increasing, all that stuff. Okay. So spill, look at it, right? So what happens here? Toxic chemicals are leaked. Response team arrives 30 minutes later. How rapidly is the radius changing? How rapidly is the area changing? Actually, the question should have been interchanged. It seems based on the question is that the leak is increasing area at an equal time. Do you agree? Just the same amount of area is added because it's a two-dimensional spill and it's like an open faucet. So let's say it runs uniformly, right? So the way we solve this, we think, okay, d a dt, the change in the area is, in 30 minutes we add 50. So so it is 50 per 30 feet squared per minute, to be precise. Yes, 50 over 30 because in 30 minutes I gained extra 50 square feet. of area. Am I right? Area or the radius? No, the radius. My apologies. It's I have to be careful here. Radius. So I need to be careful here. So they're not saying area is spilled. The radius somehow. It's the radius is. So that is 50 over 30 feet per minute. So it's not the A dt, it is the R dt. I assumed here that area is intuitively area will be increased by the same amount if it's like on open faucet, right? So the R dt, the radius is at this rate. So that means actually the pollution is speeding up. You say more and more is speeding faster and faster, right? Think about it, right? If the radius is increasing, that to increase the radius, you know, then you must actually spill more and more per time. The radius can so the area spilled cannot be constant. It's like you must be turning the faucet to higher pressure. Good. So the RDT is 50. Now the relationship between area here, it's area equal to pi r squared. So we are interested in the ADT, which is 2 pi r dr dt. Good. 2 pi r dr dt. Then what do? Then we replace r by 50 over 30. So it's 2 pi 50 over 30 times the radius is then 50 50. So that's my change in area. Good. That's the ADT at that moment. Clear? All right, I'm erasing this. Yes, guys, I'm erasing this thing. So now, how rapidly was the area of the spill changing between the time the spill was noticed and the arrival of the response team? How rapidly was it between that time? That's a bit a strange question. The area was not changing at a constant rate. Maybe they mean the average change in area. I'm not sure, right? I think maybe they want to measure the average change in area. The way this question is phrased is not clear to me, because the area does not increase at a constant rate. If the radius increases at constant rate, the area cannot be increased at constant rate, right? The area must actually be growing faster and faster. So how rapidly? So what if the solution dies?
It says defend your conclusion. What if it dies before you are able to do it? Sorry for a terrible joke.
Fine, no worries. It only gave us 2 points in time, the radius, so we don't know that it was changing at a constant. Well, it was not. The area was not changing at constant rate, right? The radius apparently, I'm presuming. Let's see how they are phrasing it. A response team arrives 30 minutes later, by which time the affected area has grown to a circle of radius. How rapidly? Yes, you're actually right. So you have to be careful here. I think they meant the average growth of radius, right? So on average, the radius grew 50 times, well, 50 divided by 30, right? That was the average. In 30 minutes, 50 feet increased radius, yes? So it might not have been constant rate. How rapidly was the area spill changing between the time of the spill was noticed and the arrival of the team? It is a dumb question overall. Yes. And it's not clearly, I mean, it's not clear. It's basically about increased circles, but it's not clear how it's changing. Right. So, I mean, do they mean instantaneously how fast it's changing, like in my notes, or do they mean at that moment, you know? Because between the time the spill started was noticed and the arrival of the team, so I think they mean average area. So you calculate one area minus the other area, and then suppose the response team plans to obtain just enough barrier to enclose a circular region with radius what is it, The response team plans to enclose the spill with a circular barrier, see figure. If it will take 90 minutes to set up the circular barrier, how long should it be? Defend your conclusion. So they are going to surround this with a barrier. It takes 90 minutes to surround this barrier. How long should that barrier be? Because they set it up in 90 minutes. Somehow, no matter how big it is, they will set it up in 90 minutes. Yes. So if it's huge, they will do it in 90 minutes. I guess they just only work well under pressure, just like you do. Right? So, yes, how long will that take? So again, I'm not, the way they are phrasing it, it's not clear at all. Right? Will the radius grow the same rate? So assuming the radius will continue growing in the same rate, you know, in 90 minutes, the circumference will grow. The circumference is 2 pi times the radius. You agree? 2 pi times the radius. So so in 90 minutes, let's see, we have the speed of 50 over 30 times 90. That would be my new radius, right? In 90 minutes, and the circumference will be how long should that that's my circumference, right? So the circumference should be 2 pi multiplied by 50 over 30 times 90. So it should be 2 pi times 50 times 3. Good. So so basically 300 pi, right? So 300 pi should be the circumference. You agree with me? Do you agree with me, guys? I need your agreement or disagreement, because do we interpret the problem correctly?
I'm not sure
Yes.
because so we already got we got the 50 over 30, right? And that was for the initial how that's the initial, like, you know, the time rate of that green circle, right? Are we
Mhm.
so are we trying to figure out like the whole, I think we're trying to figure out the whole radius of the whole circle, because if we just times it by 90, I think that's just giving it more of how long it's going to take till it hits the barrier. Is it more like that?
So here is so yes, you have to kind of be careful here. Christian, yes, Christian had something. So here is the thing. What are we dealing with here? We're dealing with, forget about the pollution and whatnot. We're dealing here with an expanding circle, right? It's really a trivial problem about a circle that expands somehow, right? So the radius is changing by what? The radius is changing at the speed of 50 over 30 feet per minute. Yes? That's the way the radius is changing. Good. Now the team, first of all, I'm not even when they noticed it, right? They noticed it when it's already the radius is initially 5,000. Yes, 5,000 feet initially, right? That's our initial. Now, what's my radius at time t? Presuming that the radius grows at a constant rate. It's very not clear what they mean here, right? Is the radius growing at a constant rate or not? It's not clear. But if it's not clear at all, why should I know that the radius grow? It doesn't even make sense that the radius should grow at a constant rate if it's pollution, right? So this question is a bit weirdly phrased. So R of t, I think it is 5,000 plus 50 over 30 t. That's how much we gain in the time, right? So in 90 minutes, it will be 5,000 plus 300. Yes? So I think what I wrote before is not entirely, because I forgot what was said, right? So it's not from initial situation. It's 5,000 plus how much we will grow. So it takes them what? It takes them 90 minutes to set up the barrier. So they will, I suppose, I mean, if they notice it at this point and right away decided to build the barrier, it will be 5,000 plus, so the radius will be out of 90 minutes later would be 5,000 plus plus what? Plus 300. Am I right? Because T will be 90. T90, it makes it not 300, sorry. If I put 90 here, it will be 50 times 3, so 150. Good. I said 300 because there was a 2 before, so it will be 5,000 plus 150. Good. Do you agree with me? I mean, you see, I forgot from which moment to what moment. So I'm presuming if it's from the moment when they notice the spill at 5,000, they will wait another, it will take them 90 minutes to set up the circumference. So it will be 5,000 plus 150. Yes? And that would be the radius. And what you have to do to it, to multiply it by 2 pi. Okay, Christian, take care then, right? You multiply it by 2 pi. And you get the corresponding circumference. Good. No. I mean, whatever. So now, so that was, I think, the answer to this part. Then what? Then suppose the response team plans to obtain just enough barrier material to enclose a circular region with a radius of 5,200 feet. However, when the material is delivered, they discover that they are 5 feet short. In other words, when they try to enclose the circular area, the gap is 5 feet. This gap is 5 feet. Since the barrier won't work unless it's closed, they have to use a smaller circle. To make the smaller circle, the members of the response team will take sections of the barrier and walk towards the center. What? I have no idea what they're talking about. What center? Well, anyhow, the question annoys me enough that I don't want to continue. Goodbye. I'm a bit tired. But you see, be careful. You see, there can be whatever questions, right? I'm not sure what's the center. I kind of don't feel like understanding it now. So, you have any questions for me? All right. I hope you so sleep well tonight. Another thing about the strategy, guys. Are you there? So make sure that when you solve those questions, you first work on questions that are easy for you and then return to the hard questions later. You don't want to waste time. Okay? Always solve the easy questions first so you have as much time as possible to work on the questions you know least well. Good luck tomorrow. Have a good rest of the day. At my open math, how? Okay, let's look at your question. So ping, how do you submit at my open math? I just I showed it a few times. Here it is. My open math. .com. You log in to your account. You log into your account, and the final will appear at 1 p.m. right? And we have, that's what I mentioned, we have practice questions. You see, we did all the practice questions here. Those are the practice questions. So how do I put the inputs here? We did it before. And I submit my work in here. So I can either type it or I can insert image or picture or attach files. Do you see that? So what you should practice is when you go home, practice those questions and see that you can submit pictures of your work. You can, let's say, take a photograph of your assignment or type something here, and you would have 30 minutes at the end of the exam time. So it's from 1 to 3, and then 30 minutes to finish submitting your work. If you don't submit work for some questions, you can be penalized, okay? So submit the work. If for some reason you see that some work you did and you were not able to submit it here, you can send me an email with it, but try to submit it all through the website. Like in here, it should be attached. There are, look at it, there are detailed showing work and uploading files, formatting practice. You see, you have all those, this is the practice, and those 2 links will tell you again how to submit work in case you're not sure. Make sure that by the time the exam takes place, you will not have any problems uploading work and you're ready with it. What other questions you have, Edwin? I think you had a question.
Hello.
Yeah, I hear you.
For my midterm,
Yes.
I sent you my midterm. The thing was, I just realized that I did it on my iPad, and I converted it to a PDF. Thing was, I only sent you 1 page, and I just realized I only sent you one.
Send me then no problem. Send me whatever you have, okay?
Okay.
Send me now what you have and I'll look at it. Good?
Okay, thank you.
Sure. All right. Anything else you need, guys? Anything else troubles you? Do you all understand what's going to happen, when it's going to happen? All right, then if you have no further questions, I bid you farewell.
Thank you, Professor.
Sure, James.
All right. Also, I just have to write down the questions, but I send to you as soon as possible.
No worries. Okay, but yes, be sure especially to know how to do everything for the exam, like how to upload. So you also have extended time. I think you received it, correct?
Yeah.
Yeah, that's good.
Okay.
Wait, Professor, how many questions did you say the final was going to be?
I think it's 16 from what I heard. I never actually looked at it, but they told me 16
Right.
questions. They're going to be most likely very similar to the questions that we did for the practice questions. And it could be that some questions are different. Let's say maybe they are from that review list. So if you know everything on the practice questions, just make sure you can do it, right? Do the today, if you have time, do all the 50 questions on the review, and then maybe look at the review posted here, this one, right? 23 pages. You can check something there. Maybe the questions that are different from the ones you've seen, maybe check those. That's the best way to prepare. Good. How do you feel ready?
So.
Yeah.
I'll study again right now, and we'll be ready for tomorrow.
Okay, I hope so. Okay, take care.
Right,
wish you well. Try to do the online problems if you can.
Yeah, well. Right.
Okay.
Thank you, Professor.
Sure. Take care.
Take care.
Take care.